Hi everyone, just wanted to take a minute to talk a little bit about arc length and measuring arcs and angles involving circles, right? So, in terms of arc length, what is it? It's a little bit different from arc measure. The arc measure was kind of was related to the degree of the central angle, right? We knew that the arc measure was a number between 0 and 360. Um, it was equal to the measure of the central angle. Arc length is a little different. So arc length is going to be the distance between the endpoints along an arc measured in linear units. So now we're not going to have things like degrees. We're going to have something like, it's centimeters, meters, inches, whatever, some kind of measurement like that. So when we look at this, our goal is to find this length right here. So, well, what do we know? What do we know? How do we find the distance around a circle? Well, normally we would find something, called the circumference, right? We would be finding the circumference of a circle, and that would give us the distance around. Now, this is only a part of it. In particular, it's a certain proportion of it. So if we kind of look at what the actual equation is going to end up being, we're just going to take our circumference, but we're only going to look at this part, right? And we know that this part right here is whatever the central angle is over 360 of the circle, right? So if this was 40, this would be 40 over 360, right? So you're essentially just looking at a certain fraction of the circumference, all right? So let's go over how to do some of these problems. Okay, so I'm just going to pull up some different problems. So the first thing you just want to always remember is that your arc length is going to be your theta, your angle, over 360 times 2 pi r. They want you to round to the nearest hundredth, so just be careful with that. All right, so we know our angle is 30. All right, so we have 30 over 360 times 2 pi, and then our radius AB here, this is 14. All right, so times 14. So before I even plug anything in, I want to simplify as much as possible. So first off, I have the 360 and the 2, so that's going to be 30 over 180 pi times 14. And I'm going to, again, take out the 2 and the 2. So that's going to be 30 over 90 times 7 pi, right? The 2 from the 14 leaves that with 7. All right, now what do I have? Well, that's just 1/3. So I have 7 thirds times pi. So at this point, you're going to plug it in. I just want to show you how you would make sure to plug it in. So if you go to your calculator here, you plug it in, 7 divided by 3, and then there should be pi, times pi, okay? So it should be 7.33, I forget what I wanted, 1,000th, 0. All right, make sure you actively hit the, 100th. Sorry. Make sure you actively hit the pi button, because if you don't hit the pi button and you put like 3.14, it's not going to make a huge difference, but it might make enough that your hundredths place is slightly off, and it'll yell at you. Just be careful about that. Okay, so do be careful with that. Let's do another one just to make sure we're on the same page here. All right. So again, the arc length is going to be equal to, I have 68 over 360 times 5. Oops, I forgot the 2. All right, so anyway, I'm going to get rid of the 2 and the 180. 68 over 180 times 5 pi. Now, is this divisible by 4? Let's take a look. Divided by 4. 17. So that appears to be 17. So that's divisible by 4. We know that 180, when you divide that by 4, right? What are you going to get on that one? 45, right? So you're going to end up with, what's this? What did I just say? 17 over 45 times 5 pi. That's what this part simplifies to. The 45 and the 5, that's going to cancel to 17 over 9 times pi. And again, you're going to plug that in. 17 times pi divided by 9, and that should give you 5.93. There you have it. All right, so do your best to simplify. If you need to leave it in terms of pi, you could have just left it as like 17 pi over 9, or over 5, I'm sorry. Or 9, nope, 9. And yeah, so that's all there is to it in terms of arc length. Let me know if you have any questions, and have a great day.